Alright, let's go ahead and start this video on functions and their graphs. After this lesson, you will be able to graph a function, obtain information from the graph of a function, know properties and graphs of basic functions, and interpret graphs of functions. Let's start off with this first definition of the graph of the function. When a function is defined by an equation in x and y, the graph of the function is the set of all ordered pairs x comma y such that y is equal to f of x. We're going to start off by graphing f of x is equal to negative x squared plus 4. It says A, determine the function's domain and range. B, identify the intercepts. Well, let's start off by graphing this because that's what it's asking for us to do first. It's asking us to graph the function. And because I see that this is an x squared function, f of x is equal to something as x squared, I already know that this shape of this graph is going to be a parabola. So when I have a parabola, oftentimes there are certain values that I like to choose for my tables when I'm making a table of values. So for this particular function, I am going to choose what I like to call my go-to values. Those happen to be -2, -1, 0, 1, and 2. Let's go ahead and substitute those in and see what values we get. F of -2 is equal to, I'm going to put a negative on the outside of the parentheses, and I'm going to put a -2 on the inside, and I'm going to square that -2, and I'm going to add 4. So this is going to give me -4 plus 4 is equal to 0. So that ordered pair is going to be -2 comma 2. And now I'm going to substitute -1 for my x. So this will give me -1 plus 4, which is 3. So my next ordered pair will be -1, 3. I'm going to substitute 0 next. So this is just 0 plus 4, which is going to give me 4. I'm going to substitute 1. So this is going to give me -1 plus 4, which is 3. And last but not least, we're going to substitute 2 for x, and we're going to get -4 plus 4, which is 0. I've got my ordered pairs. I'm ready to plot these on a graph and see what the graph looks like. Okay, so let's make sure we remember these ordered pairs as we're plotting them on our graph. I'm going to scroll down a little bit more because I happen to have a graph made right here. Okay. I'm just going to go ahead and draw some marks here to help me. I know I need to go up to 4, +4 on the y-axis, so why don't I start there? So here's my y-axis, and then I'm going to go out a few here, a few marks over here. I don't need any marks there, but I'm going to draw some anyways. I'm going to go ahead and plot my values. -2 comma 0 is going to be right here. -1, 3 is about right here. 0, 4 is right there. 1, 3, 2, 0. Now I'm going to connect my points to draw my graph, and I'm going to make sure I extend my graph all the way to the very ends of the graph here. going to go and I'm going to label my points because I know this is going to make my professor very happy when I do this. There we go, we labeled everything. And the name of this graph happens to be y is equal, oh, we're using f of x, we're using function notation. So remember, we're using f of x is equal to negative x squared plus 4. So I believe I've got everything on my graph there, the way it should look. Now, it's asking us to determine the function's domain and range. I can tell that the domain, because you see these arrows down here, it doesn't look like it. It looks like they're going straight down, but they're actually going like towards the left and towards the right, right? Towards negative infinity on the x and towards positive infinity on the x. So my domain is going to be the open interval from negative infinity to infinity, or another way that we could write this would be the set of all x such that x is an element of the set of real numbers. My range, these are the y values, so instead of looking from left to right, I'm going to look down, up. Down, it looks like this function is going down towards negative infinity, so I'm going to, right here, that's why it's going downward, right, on both sides, going down. And the highest value, or another way to call this value, sometimes we call it the maximum when it's a parabola that's opening down. The highest value that it goes up on the y is going to be up to 4. So we're going to call this the half open or half closed interval, right? Always parenthesis on infinity. Infinity is not bounded, right? That's why we use parenthesis on infinity. And then 4, it's closed on 4, so we're going to use a square bracket. Or another way we could write this would be the set of all y such that y is less than or equal to 4. So make sure that if you are providing this information, especially like on a test, that you are boxing in this information so it's easy to find. Alright, next. It's asking us to find the intercepts. The intercepts are going to be all of the points that cross either the y-axis or the x-axis. So I'm going to be a little bit more specific than just listing off the intercepts. I'm going to actually write in the y-intercept. So the y-intercept is going to be 0, 4, and the x-intercepts are going to be at negative 2, 0 and 2, 0. Let's go ahead and box those in. So there's my y-intercept, and here are my x-intercepts. Oops, that doesn't look very good. See if I can fix that. That looks a little bit better. And I think I've answered everything for that one. Let's go down. Let's go to the next one. The 0 of a function. If f of r is equal to 0 for some number r, then r is a blank of f. And what we want to write in there is we want to write in there the word 0. For example, if f of x is equal to negative x squared plus 4, then the zeros of f are, well, we could actually look up here and figure it out. Remember what it's saying here, right? F of r, or you can imagine f of x, is equal to 0. So if we were to look at our table of values up here, the f of r, that's like the f of x. When was this equal to 0? Here and here. What values created those zeros? It was -2 and it was 2. It just so happened to be the x coordinates of our x-intercepts. So a quick way of identifying zeros is by looking at your graph, finding, well, where are the x-intercepts, and then looking at the x coordinates of the x-intercepts. So those x coordinates of the x-intercepts are zeros. Now I know that -2 and 2 aren't really 0, but what they do is they create or they produce zeros when you substitute them into the function. That's why we call them zeros. So it's not necessarily that, a number doesn't have to be 0, right, to be a 0. It's a number that will make y equal 0 once you substitute it in for x. That's what we're going to call the zeros. Another way of identifying the zeros, right, if we say we didn't have this information and all we had was this function or this equation, is I could have set this equal to 0 and then I could have solved this equation right here. Well, I could solve this by factoring out a negative, and then I have the difference of two perfect squares, which factors into x plus 2 and x minus 2. And then I could set each one of these factors equal to 0. This is the zero product property. And then I can solve each one of these equations. So I get x is equal to -2, and I get x is equal to +2. Thus, those are the zeros. So the zeros of f are going to be -2 and 2. Okay. Oops, I think I went down too much. No. Perfect. Alright, the Wonder Wheel. The Wonder Wheel is a Ferris wheel in Coney Island. Let F be the distance in feet above the ground of a person riding in a car on the Wonder Wheel as a function of time x in minutes. Use the following graph of F to answer the following questions. I know there are no questions written down, but I'm about to write them down for you. So let's go ahead and write these down. For A, I want you to find f of 1.5 and f of 3. And then we're going to interpret these values. Let's go ahead and start off with f of 1.5. F of 1.5, I would need to look on the graph and see where my x value of 1.5 is at. So let's go ahead and look for 1.5 for x. Here it is. That's where x is equal to 1.5. Now let's see what is the y value that is produced when we substitute in 1.5 into our function. We get an 85. So f of 1.5 is equal to 85. Now, what does that 85 represent? Well, if we look at our word problem right here, it said let f be the distance in feet. It's right here. Above the ground, right? Of a person riding in a car on the Wonder Wheel. So this 85 here, this 85 represents feet above the ground. Let's go ahead and write a little explanation of what it represents. So it's basically saying at 1.5 minutes A person will be 85 feet above the ground. Okay, so let's go ahead and box in everything we just found right now. We found a lot of good information here. That looks pretty good. Now let's find the other one. F of 3. F of 3 says, or F of 3 is going to be equal to, let's see, I'm going to erase what I highlighted up here so it stands out a little bit more for us. I'm looking for 3, where x is equal to 3. X is equal to 3 at this point right up here. And then I look for see what the y value is. The y value that corresponds to that x value is 160. Therefore, f of 3 is equal to 160. But 160 what? It's going to be equal to 160 feet, right? And now let's explain exactly what this 160 feet represents and what that 3 also represents. As soon as I can box this in. So I'm going to write, maybe we can bring this down a little bit lower. Just a little bit. So I'm going to write here, let's use a different color. At 3 minutes, a person will be 160 feet above the ground. And that's my little explanation. All right, we're moving right along. I want to keep, well, let me write down the question first and then I'll scroll back down if I need to look at the graph again. It asks, our next question is going to be, what is the domain of f? Domain, remember, that represents the x values in the graph. Let's look at our graph again. So notice that there are no arrows on the ends of the graph, so it's not going towards infinity this time. The endpoints actually stop. So it looks like it starts up. Maybe that's not the best color. Let me use another color. Let's use yellow here. It starts right here for the x values at 0 and it goes up to x equal to 4. When we look for domain, we're looking from left to right. So remember, you're starting on the leftmost value for x, or the smallest value for x, and you're working your way right to the largest value for x. That's how we look for domain. You need to train your eyes to look from left to right. So this would be the set of all x such that x has to be greater than or equal to 0, or x is less than or equal to 4. We could also write this as the closed interval from 0 to 4. So that's going to be our domain. I'm going to box that in. Next question, what is the range? Let's call this C. So in order to find the range, now instead of looking from left to right, I need to train my eyes to look from down up. down to the lowest value for y, up to the highest value for y. So looking down up, the lowest value would be the 10. If you notice, all of these points, none of them touch the x-axis. The highest value that it goes up to is 160. So if I've trained my eyes to look from the lowest value, right, we're going from down, up, to find the range. My range will then be the set of all y such that 10 is less than or equal to y and y is less than or equal to 160, or the closed interval from 10 to 160. For what values, oh, let me write down the next question. I'm already reading it out loud and I haven't even written it down. Oh, and I also haven't boxed in my answer. I want to emphasize, can never emphasize how important it is for you to box in your answer. You want to make life easy on your teacher by making sure they can find your answer. Alright, D. For what values of x does f of x equal 85? That is, solve f of x equals 85. So notice that they're saying in this problem, solve, right? Like find a solution. So when we write this, we're going to make sure we write it as a solution set, or you're going to write x is equal to something, right? So in order to find where f of x is equal to 85, let's go back to our graph and see where the y values equal 85. So it looks like the y values equal 85 here, here, here. Oh, and I missed one. It's right here. I'm going to see what were the x values that produced those values of 85 for y. It looks like 0.5, 1.5, 2.5, 3.5. Let's go ahead and write down all of those as our solution. So it's okay if you want to write down x is equal to 0.5, 1.5, 2.5, and 3.5. Or you could also write this as a solution set, 0.5, 1.5, 2.5, 3.5, and close your solution set with a set of braces. Let's go ahead and box that in. Perfect. And those were all the questions for that one right there. Let's go ahead and move on to the next one. Moving right along. Use the graph of y equal to f of x to answer the following questions. Let's start off with A. Find f of negative 3. F of negative 3, I'm going to look where x, remember this represents the x part right here. Where is x equal to negative 3? Ah, here it is. What's the y value that goes with that x? Oh, it's negative 15. So this is going to be negative 15. The other part to this one was find f of 1. Once again, this is the x right here. Where is x equal to 1? Ah, here it is. What's the y value that corresponds to that x value? It's negative 3. So this is going to be equal to negative 3. B, what is the domain of f? The domain of f, if you notice there's arrows on the ends of this, It's going to the left all the way to the right. So it's going to negative infinity all the way to positive infinity. So we're going to say the domain is going to be the closed, not closed, because it's infinity. Infinity is not bounded. The open interval from negative infinity to positive infinity. Or we could also write this as the set of all x, such that x is an element of the set of real numbers. Let's go ahead to C. What is the range? So the range, if you notice that the arrows, they go down, up, down towards negative infinity, up towards positive infinity. So the range is the open interval from negative infinity to positive infinity, or the set of all y, such that y is an element of the set of real numbers. Haven't been boxing in my answers. What kind of an example do I expect myself to be? Let's box these in. Much, much better. D, identify the intercepts. They didn't specifically state to write out like which one was the y or which one was the x. So I'm just going to go ahead and list out the intercepts. One of the intercepts is going to be right here. This is going to be at negative 2, 0. That's one of the x-intercepts. The other intercept is going to be right here. This happens to be both an x and a y-intercept at 0, 0. And then the last intercept is going to be right here. That's going to be at 2, 0. Those are all of the intercepts, x's and y's, right? Just y, just one y intercept. For what value of x does f of x equal 15? So I'm going to go ahead and look to see where my y value, because remember that when it says f of x means the y value. It's basically saying, when is y equal to the 15? So let's see which ordered pair here has a 15 in the y value. It's this one right here. And the x value for this one is a 3. Therefore, x has to equal 3 in order for y to equal 15. So you could write this as x equals 3, or you could write this as a solution set 3, like that. So I'm going to go ahead and box that in. And what are the zeros? We talked about this earlier. The zeros are going to be the x coordinates of the x-intercepts. So I'm going to go ahead and just write those down. I'm not going to put this in a solution set. This does not represent a solution for x. It's just that we call these the zeros. So it's going to be negative 2, it's going to be 0, and it's going to be 2. And if anyone's wondering, how did she come up with those? Well, we actually could have used the x-intercepts that we had right up here and just looked at the x-coordinates. Negative 2, 0, and 2. So that's where they came from. Okay, let's move in right along. Consider the function f of x is equal to 3/2 x minus 1. Is the point negative 2, negative 4 on the graph? I don't know. Let's find out. This is my x, this is my y. We're going to substitute these in and see what we get. If it is on the graph, we should end up with a true statement. So this is for part A. F of x is equal to 3/2 x minus 1. But instead of f of x, I'm going to substitute negative 4. Instead of x, I'm going to substitute a negative 2. And now this is going to turn into a negative 6 over 2 minus 1. Negative 6 divided by 2 is going to give me negative 3, and negative 3 minus 1 is going to give me negative 4. Yes, this came out true. See, both of these things are the same. So yeah, since this is a true statement, I'm going to say yes, this point is on the graph. So the answer is yes. negative 2 comma 4 is on the graph of f of x equal to 3 halves x minus 1. Part B. Is x equal to 4? If x is equal to 4, what is f of x? I don't know. Let's find out. I'm going to copy down my function one more time, and then I'm going to substitute the x with a 4. So f of 4 is going to be equal to 3 halves times 4 over 1. 3 times 4 is 12 divided by 2. That's going to give me 6, and 6 minus 1, that's going to give me a 5. So it looks like f of 4 is equal to 5. So let's go ahead and write that down. F of 4 equals 5. Now there's a part 2 to this question, so we can't forget this part right here. What is the point on the graph? The point on that graph is going to be 4 comma 5. This was a two-part question. We got to be careful. That was kind of tricky. If you would have missed that second part, you would have lost points on the test. So don't do that. If f of x is equal to 8, what is the value of x? I don't know. Let's find out. So I'm going to go ahead and copy down my function one more time. F of x is equal to 3 halves x minus 1. I'm going to substitute. Instead of f of x, I'm going to write an 8. Because they're telling me f of x equals 8. So I'm replacing this whole f of x with an 8. And now I'm going to solve this equation for x. Plus 1, plus 1, 9 is equal to 3 halves x. I'm going to divide both sides by 3 halves, but when I divide by fractions, I'm actually multiplying by the reciprocal. So why don't I come on over here? So x is equal to 9 divided by 3 halves, or x is equal to 9 times the reciprocal of 3 halves, which is 2/3. This is going to give me 18/3, but 18/3 will reduce to 6. So I guess the answer to that question, when it said what is the value of x, x is equal to 6. You can write it like this right here, right? And what it says, what point is on the graph of the function? The point that is on the graph of the function is going to be 6 comma 8. All right. I think I answered everything. The last page that I have on this handout, it is just some basic graphs. So I'm not going to go over that. You guys can go over that if you have my handout. You can just look over those graphs and make sure you memorize them. All right, that's it. Thanks a lot.